Okay, guys, we got through, I believe, number 15 in class, and yeah, both of the classes. So I'm going to go on to number 16, just to give you another example of one of these types of problems. Okay, so this is number 16, and we're going to do it graphically, and we're going to do it algebraically. Hopefully, we'll see some commonalities between the algebra and what happened graphically. The whole idea here is, and this is really prepping you for algebra 2 trig type stuff, because you do a lot of graphing, a lot of algebra, a lot of relating the algebra and the graph and seeing how they relate to each other. Okay, so we're going to look at this circle here, and you know by what we did in class that the center of this thing is -2 and 3 for the y. The radius squared is 81, so the radius is 9. Okay. And I can go ahead and do a rough graph of this circle. Center -2, 3, and a radius of 9. So I'm going to count off 9 units. It's going to be over here. 2, 4, 6, that's 7, right? Go down 9. So I got to go down 6 more. 1, 2, 3, 4, 5, 6. 9 is going to put it off the graph here, and then it's going to put it off the graph up here. So this is at 3, this is 7, 8, 9, somewhere up here. And we want to know, so we got an idea what this circle looks like. And it's hard to graph perfectly, right, with your hand. If you had a compass, you could graph it kind of nicely. Okay. So there's my circle. I want to find the coordinates, the points on the circumference, on the circle itself. Remember, any point on here satisfies this equation, right? But there are points on there that might have an x coordinate of -11. So think about it. Here's your x-axis, here's your y-axis, right? Where is my x value of -11? Well, -10 is over here, -11 is over here. It looks like it might touch somewhere in there, right? But in general, what I know is when I went from -2, we went from -2 here, for the x-coordinate, we went 9 units to the left, and so this axis should be at -11, right? It looks like there's only one value. Let me do this again. I want to make sure I count correctly. We're over at -2. We got to go 9 more left based on the radius. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 left, and there's an x-coordinate of -11 right there, right? So that didn't take very much there to figure out that solution. It's just x equals -11. If we were to graph that line, we'd see this line going flush, what we call tangent. The word tangent comes from this. This would be a tangent line to the circle because it only touches in exactly one place, okay? If it crossed through 2 places, we call it a secant, but we're going to get into that later. But this line actually touches the circle only once. This is at the point -11 and then up at 3, right? Because it's straight over from the center. So this is at -11, 3. That should be our 1 point. That should be our solution if we do it algebraically as well. Okay. So let's go over here and see what it looks like when we do it algebraically. I'll do this in green. We're going to write down our equation. We have our equation. We're doing it algebraically, so we must have an equation somewhere, right? And indeed we do. We have our equation right here. But the x-coordinate is -11. So what we're going to do is we're going to substitute let x equal -11. We're going to plug that in for x. Not too complicated. -11 goes in for x. Now y is still y, and we're trying to find y, so that's good that we still have a variable in our equation. And so we have some algebra to do, right? Let's simplify this. -11 plus 2 is -9, and then I square it, I get positive 81. And I get y minus 3 in parentheses squared here. And on the right, I get 81 as well, because I already had 81. So look what's happening algebraically. If you remember what happened before, we had different numbers on both sides. So when we subtracted, we still got a number on the right side that wasn't equal to 0. But look what happens when we solve this. I want you to think, guys, when you see this little complicated here, I want you to think, what if you had 81 plus some variable? Let me call it n. Let me stay away from x's. Okay. How would you isolate that? Our goal is to isolate this so we can solve for y, but y is stuck inside this squared function. Okay. So we want to solve for it so that then we can take the square root and then we can add 3 after that. Okay. But we can't do that until we isolate this. So how would I isolate that? Well, I'd subtract 81 on both sides. And I get n equals 0, right? But we didn't really have to do that. I just wanted you to see that if I let n equal y minus 3, we could have substituted in there to make the equation look a little easier, to show you why we have to isolate. Now n is not n. N doesn't help us, right? We're trying to find the y value. But n is y, n is y minus 3 squared, my fault. N is y minus 3 squared. So I'm going to substitute back in y minus 3 squared equals 0. Now, we went through this in class. What happens when you want to solve for this? You have to take the square root of both sides of the equation. Okay? When you take the square root of both sides of the equation, you get y minus 3 squared and then the square root. So this green square root symbol undoes the orange squaring. Those are inverse operations, which gives you back whatever was inside there. On the right, we got square root of 0. Square root of 0 is 0. There's no plus or minus because plus or minus 0 is the same. You don't have, 0 does not have any sign. Normally, we would do plus or minus here, but it doesn't really matter. Plus and minus 0 is the same. So now all you got to do is add 3 to both sides. And we get y equals 3. Okay. Now, remember, the problem started with letting x equal negative 11, and we got y equals 3. So our solution is x equals negative 11, and y equals 3. So as a coordinate, it would be written like that. And indeed, that matches what we saw. So look what happened. When there was only one solution, it was because we got plus or minus 0 over here, right? That graphically, we can see the line ends up being tangent and barely touching the circle. So we got exactly one solution there. Okay. Okay, let's go down to the next one. Stop and replay that one if you need to. Number 17, we're going to graph this one again. I may go back and do number 15 on another video if I can fit it. Okay, we're going to do x equals, the center is at negative 4, 1. You should be able to graph this. Stop, and if you want to graph it on your own and see if you got the same thing I did. But I'm going to go through this pretty quick. Negative 4, 1 is up here. That's my center point. We have a radius of 5. So I'm going to count over 5 units from here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's roughly what my circle looks like. Okay. Now I want to know where on this circle I will have an x coordinate of 2. We're going to continue this on another video, but look, at x equals 2, my line x equals 2, this line represents all the points where x equals 2. There's no value on this circle where x equals 2. There is no solution. We're going to continue the algebraic portion on the next video.